Hey there. Today in this video we're going to look at how do you solve linear inequalities. Linear inequalities pretty much are solved the same way as linear equations. You want to get your x's to one side of that inequality symbol and you want your constants on the other side of that inequality symbol, and then solve x is greater than or x is less than, whatever that happens to be, with one exception. Okay, and that exception is whenever you multiply or divide by something negative, by a negative value, well then you must flip the inequality symbol. You must reverse the inequality symbol. Okay, so we are going to solve these inequalities, all right? And we should be able to just walk through them just like we would an equation. And anytime that we multiply or divide by something negative, only something negative, then we're going to flip that inequality symbol around. All right, so let's try this. 3 times the quantity x plus 1 is less than 7. If you saw this in an equation, what would you do first? You would distribute, so let's do that. 3x plus 3 less than 7. All right, now let's isolate this x. We need to first get rid of the constant 3 and then the coefficient 3. So subtract 3, 3x is less than 4, and then divide by 3, x is less than 4/3. Okay, this is well and good, but we have to write our answers as intervals. Remember how we do intervals. We need to go this way. Let's just do a mini number line, right? Here's 4/3, and we're going this way from 4/3. So we need starting, ending in our interval, or negative infinity to 4/3. All right, moving on. Okay. You could, if you wanted to, just go ahead and divide out that -6, but I do notice that we're going to get a fraction right away, and many of you would kind of freak out with that, so let's go ahead and distribute. We'll still get a fraction, but it's going to end up being not till the last minute, okay? So -6x, -18, less than or equal to 10. Adding an 18 to both sides, -6x is, less than or equal to, add the 18, 28. Okay, and then divide through by the -6. Oh, divide by negative, what do we have to do? Reverse that inequality symbol. Okay, so x is greater than or equal to 28 over -6, which would reduce to 28 over -6 that has a common factor of 2, or -14/3. And again, we're looking at a number line, -14/3 here, and we're going this way on the number line. Notice we have a bracket because this time we've got an equal sign there. So we're going from -14/3 to infinity. -14/3 to infinity. Bracket on that -14/3. Right, here we go. 6x minus 14, less than or equal to 4x minus 15. All right, so we want to collect our x's to one side, constants to the other. Now, you can collect anything you want to the left or to the right, but I'm always bringing it to where I've got more x's. So I'm going to subtract 4x here, and I'm going to add my 14 to the other side. Okay, so these cancel. These cancel, and I end up with 2x less than or equal to -1. That's pretty easy, because then I just divide through by a +2. Do I flip it when I divide by a +2? I do not. Only when a negative. Okay, so x is less than or equal to -1/2. Here's my quickie number line, -1/2, and I'm going this direction from -1/2, so it's from 2. from negative infinity to negative 1/2 with a bracket on that negative 1/2. Last one over here. Let's go ahead and divide through, let's go ahead and distribute through here, and then we'll collect our like terms. We have 8x plus 8 plus 2 greater than or equal to 9x plus 17. So I have 8x plus 10 greater than or equal to 9x plus 17. Let's go ahead and get rid of our x's on the left-hand side, bring them all over to the right, and let's get rid of our constant on the right and bring it over to the left. Remember that when you do this, you want to eliminate the constant from one side, the variable from the other side, or else you're just going to get it all to one side of the equation, or the inequality. So we have negative 17 greater than or equal to x. This is a correct answer, but truly in inequalities, we find it to be more intuitive and proper to have the x on the left-hand side. So we're going to take this whole inequality and flip it around. Okay, so x is over here on the left. And now when I do that, notice I want to keep the inequality pointing at the x. So x is really less than or equal to negative 17. And so here's our nifty number line, negative 17. We're going that way from negative 17, everything less than negative 17, right? So negative infinity to negative 17. Oops. So there are some special kind of inequalities that we need to be equipped to handle. Sometimes we have inequalities where there's nothing that will satisfy them, or there's no solution. Sometimes we'll have inequalities where it doesn't matter what you sub in, it is true. Sometimes we'll have what are called compound inequalities, where you actually have kind of two statements in one. And all of these are a little bit special, and they're something you should know how to do. So let's fill in the blanks of the notes, and then we'll do some examples. When solving a linear inequality and the variables cancel out, leaving a false statement. If you end up with your variables dropping out as you are solving, and you get a false statement like 2 is greater than 5, false, then the solution is no solution. There is nothing that will satisfy it, or like null symbol, right? But when solving a linear inequality and your variables cancel out and you're left with a true statement, such as 5 is greater than 2, something true, that would mean that your answer is all real numbers. Negative infinity to positive infinity, or all real numbers. Okay, so we're going to do these two examples, which are going to be examples like this. Then we'll come back to our compound inequalities. So let's take a look. 3 times x plus 1 is greater than 3x plus 2. Let's distribute. 3x plus 3 greater than 3x plus 2. All right, so go ahead and subtract your 3x from both sides. And I get 3 is greater than 2. And I look at this statement and I notice my variable is gone. So at that point I say, okay, this is either a no solution case or an all real numbers solution case. And I just decide, is this a true statement or a false statement? I know 3 is greater than 2, so this is true, which means that my answer will be all real numbers, or negative to positive infinity. Let's try this one. 3x plus 1 less than 3x minus 12. Again, let's get rid of our variables by subtracting 3x on both sides. And I get a resulting statement of 1 is less than negative 12. 1 is less than negative 12. True or false? Well, we know 1 is actually greater than negative 12, so this is a false statement, which means that my answer is no solution, or the null set. Okay, so the last thing here is solving a compound inequality. Really, The only difference in solving compound inequalities and regular inequalities is whatever you do to isolate the x in the middle, you're going to do it on both sides as well. Okay, so let's write that down. Take steps to isolate x in the middle of the inequality. Same steps must be taken on the ends. Okay, so what you're doing really is you're looking at this middle section and you're saying to yourself, how do I get this x by itself? All right, whatever you do to isolate that x in the middle, you're going to do it on the left side, in the middle, and on the right. It's very easy. So let's go ahead and think about this. If I wanted to get this x by itself and isolate it, the first thing I would do would be subtract this 5. So subtract 5, subtract 5, subtract 5. This becomes negative 10 minus 5, or negative 15. Less than or equal to, these cancel, 3x. Less than or equal to, 10 minus 5 is 5. Close. One more step. We need to get rid of this 3. So we're going to divide everything through by 3. And then we see that negative 5 is less than or equal to x, which is less than or equal to 5/3. What this really says is our solution set is everything between negative 5 and 5/3, including those endpoints. So on a number line, we would have negative 5 and 5/3, and we would have everything in between there included. So negative 5 to 5/3 would be our solution set. All right, so over here to this one. Same idea. Let's go ahead and isolate x. What would we do first? I think that we would add 2 everywhere, getting rid of the constant in here, okay? So let's add 2. Add 2, add 2. So that would give us negative 15 is less than or equal to negative 3x, which is less than or equal to negative 12. So now I'm going to divide everything through by that negative 3. That what? That negative, I'm dividing by a negative. What do we need to do then? Flip those inequality symbols. So if I divide by negative 3 and negative 3 and negative 3, and I remember that I'm going to flip my inequality symbols, right? So this becomes 5 is greater than or equal to x, which is greater than or equal to, that's negative 3, 4, right? Okay, and so this is a correct statement, but when we're dealing with compound inequalities, it's really kind of proper to have it going from left to right, least to greatest. Notice that our 4 is actually on the left of the number line, so we're going to flip it all the way around. 4 is less than or equal to x, which is less than or equal to 5. And then our solution set would be from 4 to 5 inclusive. So that's a brief lesson on how to solve linear inequalities. We will pick up next time when we talk about other kinds of inequalities. Oh, they're fabulous. Absolute value inequalities, polynomial inequalities, including quadratic inequalities, rational inequalities. Oh, just mathematical heaven.